Hey everyone, so today's video would be about truth table, conditional statements and few more types of statements. So starting off with truth tables. Truth table is a tool that helps you to analyze whether statements or arguments are logically true or not. Truth tables represents how truth or falsity of a compound statement depends on the truth or falsity of the simple statements from which it is constructed. So the definition is very self-explanatory that the compound statements truth or falsity will be depending upon the simple statements that we took and used to create the compound statement. Now suppose the simple statements that we took were P and Q. So the truth table of statement Q and P will look something like this, where in the first column I have taken the statement P and all its possibility of being true or false. In the second column we have taken statement Q and all its possibility of being true or false. Now these two, as we have studied earlier, that these two are the compound statements. This statement is P or Q. This is P and Q. These two are made using the logical connectives or and. So when the case is that statement P is true and statement Q is true as well, then the compound statement that we have constructed using OR will be true, and the compound statement that we have constructed using AND will be true as well. Why? Simply because these two statements are true in the first place. Now when P is true but statement Q is false, then this compound statement which was constructed using the logical connective OR will be true, but the compound statement that was constructed using the logical connective AND will be false. Why is the case? Because when we are saying P or Q, we are choosing either of P or Q or both. We are saying that if Q is true and P is false, then yes, the compound statement P or Q can be true, or if P is false and Q is true, then yes, the compound statement P or Q will be true, simply because we have passed down the condition that either of the statement can be true for the compound statement to be true. But this is not the case with AND. When we have used AND to create the compound statement, we are saying actually that both the statement has to be true in order for the compound statement P and Q to be true. And this is the concept of logical connectives OR and. When we are saying AND, we are including both of the possibilities, that P has to be true and Q has to be true in order for the compound statement P and Q to be true. The same case is with when P is false but Q is true. Here the statement P or Q will be true, but the statement P and Q will be false, simply because in case of P or Q we have the condition that either P can be true or Q can be true for the statement to become true. But when we are saying P and Q, we have passed the condition that both the statement has to be true. So P or Q will be true and P and Q will be false when the statement P is false and statement Q is true. The last case, where both the statements are false, where P is false and Q is false, we will see that the compound statements P or Q will be false and P and Q will be false as well, because both the prior statements were false. So the compound statement that we get using the logical connectives and or will be false as well. Now, truth tables are actually really helpful in checking the truth or falsity of conditional statements, converse statements, inverse statements, and contrapositive statements. All of these statements will be seeing further. So, starting with conditional statements, as the name suggests, that there would be a condition given in the statement. Conditional statements looks like this, where you can read it as if P then Q, meaning that if P happens then Q happens, and if Q has happened, then in the background P must already have happened. So how do we read conditional statements? This can be read as statement P implies statement Q, or statement Q is implied by statement P, meaning statement P is implying to statement Q, it is directing, it is pointing towards statement Q that if P has happened, then Q will happen. And statement Q is implied by statement P, meaning if Q has happened, then P has already happened in the background. Here P is called the antecedent or the hypothesis. It is actually something that we assume or we expect it to happen. We are saying that P is the hypothesis that we are looking forward to get into. P is the result that we are looking forward to get into the observation, and Q is called the consequent or result. It is the conclusion that happens actually when we are stating a conditional statement. So we can remember P as the hypothesis, something that we are expecting to happen, and Q as the result or the conclusion, something that actually happens. Now, to understand conditional statements with an example, suppose I define statement P as I travel by train, and I define statement Q as my journey will be cheaper. So the conditional statement that we can generate using P and Q will be, if I travel by train, then my journey will be cheaper. This is the conditional statement. Here I have using a condition that if I travel by train, if I am going to travel by train, then my journey will be cheaper. So if we make a truth table using P and Q, from earlier we have again used the truth values of P in the first column, where P is true, true, false, false, and Q can be true, false, true, false. So the truthness or falsity of P implies Q can be written as when our hypothesis is true and the conclusion is true as well, meaning when P is true and Q is true as well, then the conditional statement P implies Q will be true. How will be it true? We can see it that when I say that P is true, it means that I am indeed traveling by train. And when I say that Q is true, then yes, it was true that the journey is cheaper. So both the antecedent and consequent was true, hence the conditional statement will be true as well. Now when P is true and the conclusion Q is false, then our conditional statement P implies Q will be false. How will be it false? When it was said that P is true, then it means that yes, we travel by train, but the journey was not cheaper. When I said that P implies Q, the statement was defined as if I travel by train, then my journey will be cheaper. We are passing a condition here that traveling by train will make the journey cheaper because train is cheaper here than other means of transport. But when we are saying that P is true and Q is false, then going by train is in fact not cheaper, it is costlier. Hence, the statement that we have written, the conditional statement, is false. Why? Because the conclusion that we were expecting at first has come out to be false. Hence, the conditional statement is false as well. When the hypothesis is considered to be false, when we have said that the statement P, that what we were expecting is false, but the conclusion that we actually get is true, then the conditional statement will be true. Now this is something that we need to look into more attentively. Now, when we say that P is false, when the hypothesis in the first place is false, it it is saying like the things we were expecting to happen is false. But we are saying that Q is true. Here, if we go back to our statements, it means that I did not travel by train. The statement P was I travel by train. But when we are saying that statement P is false, it means the person did not travel by train. But the truthness of statement Q says the journey will be cheaper. If we word this statement, it would be like I did not travel by train, but my journey would have been cheaper. Here it is like we are talking in retrospect, where the prior possibility didn't happen, but the conclusion that we were expecting is bounded to happen. So we did not travel by train. The journey may be cheap, but we cannot disapprove of it. We cannot say that no, we have not taken the train, so the journey would not be cheaper. We, in fact, cannot say that the conclusion will be false simply because the hypothesis is false. So, in case of conditional statement, when P is false and Q is true, then P implies Q will be true. And in the last case, when our hypothesis is false and our conclusion is false as well, then P implies Q will be true. It's like saying we did not travel by train and our journey wasn't cheaper. It means yes, the person took some other means of transport and his journey wasn't cheaper. We defined P implies Q as if I travel by train, then my journey will be cheaper. There was a condition that traveling by train would make the journey cheaper. But we did not travel by train in the first place and the journey wasn't cheaper. So the conditional statement P implies Q will be true because both our hypothesis and our conclusion was false. So the important point that we need to keep in mind is that conditional statement is false if and only if the antecedent is true and the consequent is false. In case of conditional statements, we will only be saying that the conditional statement is false when the result that we expected to happen is true and the result that actually happened is false, meaning the hypothesis that we have generated, it was something that we were expecting it to happen, but in fact the conclusion or the result that we get is false. It did not actually happen. So the conditional statement will be false in that case. In all of the cases, the conditional statement will be true. Now there are few equivalent forms of conditional statement that we should look into. When I say P is implying Q, then it can also be said in a way that P is sufficient for Q. Now here is a short concept of sufficient and necessary conditions. P is sufficient for Q means that happening of P, or when P occurs, it is sufficient for Q to happen, meaning Q has all the adequate resources to happen. When and conditional statement can be stated in another way, that is Q is necessary for P. Here, if Q happens, Q is the conclusion that is happening. If Q happens, then in the background P must have happened, meaning the occurrence of Q is necessary for occurrence of P. It's like saying that we gotten the end product, so the prior situation must have happened already, which is P. So when it is said that Q is necessary for P, it means that occurrence of Q is necessary for P to already happen in the background. And so conditional statement is also called P implies Q, and P only if Q, and Q follows from P, meaning since P is the conclusion, Q is followed after P. These are all the equivalent forms of the conditional statement. Now let us look into few more important statements, type of statements. The first one is converse statement. If P implies Q is given, then the converse of the conditional statement P implies Q is Q implies P. We just have to swap the order of the conclusion and the hypothesis to get the converse of a statement. Now to explain this with an example, suppose the conditional statement P implies Q was if it rains, then the grass is wet. Then when we write the converse of P implies Q, it would be if the grass is wet, then it must have rained. This is how we can write the converse of a conditional statement. Now inverse statement is when P implies Q is given, and inverse of a statement is when we negate both the hypothesis and the conclusion. The last type of statement is contrapositive statement. It is when P implies Q is given, then the contrapositive of this statement can be written as when we swap the order of the conclusion and the hypothesis, and we also negate both of them. It's like saying if P implies Q was if it rains then the grass is wet, then its contrapositive statement would be if the grass is not wet, then it must have not rained. Here we have swapped the order of conclusion and the hypothesis, and we have also negated both of them. Now using the same example and to see how the converse, inverse and contrapositive of a conditional statement look into the truth table, we have taken here the same example that P was defined as it rains, Q was defined as the grass is wet. Then P implies Q would be if it rains, then the grass is wet. And to write the similar truth values of P and Q, P is taken here as true, true, false, false. Q is true, false, true, false. And the conditional statement P implies Q is true, false, true, true. All of this we have seen earlier. Now to write the inverse and the contrapositive, we would need the negation of P and Q, and it is good practice to already write the negation of the statement, so it won't become a hassle for us to first convert the statement into its negation in our mind, then write the inverse and contrapositives. So when we want to negate the statement P, we simply have to invert the truth values. True becomes false and false becomes true. So the negation of P becomes true, negation of P becomes false, false, true, true, and negation of Q becomes false, true, false, true. Now, now to write the converse of P implies Q, it would be Q implies P, and now we simply have to follow the previous process of writing conditional statement. Here Q has become the hypothesis and P has become the conclusion. So when the hypothesis is true and the conclusion is true, the resultant P Q implies P would be true as well. When the hypothesis is false but the conclusion is true, we have already seen that the concluding statement, that is P implies Q implies P, would be true. When the hypothesis is true but the conclusion is false, we know that the Q implies P would be false, and when both are false, we know that it would be false. Similarly, we can write for the inverse and contrapositives. For the inverse, we have to look at negation of P as the hypothesis and negation of Q as the conclusion. So when both the hypothesis and conclusion are false, we know that the conditional statement is true. When the hypothesis is false and the conclusion is true, the conditional statement is true. When the hypothesis is true but the conclusion is false, the conditional statement is false, and when both the hypothesis and conclusion are true, then the conditional statement is true. This is how we can write the truth values of inverse. Similarly, for contrapositive, we have to look at negation of Q as the hypothesis and negation of P as the conclusion. When both are false, conditional statement is true. When hypothesis is true, conclusion is false, the conditional statement is false. When hypothesis is false but the conclusion is true, the conditional statement is true, and when both are true, the conditional statement is true. Now, a thing to notice here was that the truth values of conditional statement of P implies Q and the contrapositive are identical. Similarly, the truth values of converse and inverse statement are identical. When the truth values of statements of the conditional statements or its inverse, contrapositive or converse is identical, then we have to say that these statements are logically equivalent statements. Logically equivalent statements are those statements that shows identical truth values in the joint truth table. So when two statements have the same truth values, then we can say that those are logically equivalent. So this was all about truth tables, conditional statement, and few more types of statement that we have seen. Thank you for watching.